All right, folks, it's about 2:30 Eastern time, so we're going to go ahead and get started on time because we got a lot of ground to cover. So good morning, good afternoon, everyone. Thanks for joining us from wherever you are. Today's webinar is Podium Building Design with RISA and ADAPT. My name is Alan Mitchell, and I'm joined by my colleague, Nate Spurley. We are technical sales engineers with RISA. Before that, both of us were structural engineers using RISA and ADAPT products in the consulting and design world, including building structures design. I used RISA products for the most part, and Nate is our expert in ADAPT post-tension design. So today we are joining forces for the topic of this webinar, Podium Building Design. So, let's take a second, and hopefully if anybody can't hear me, they can catch up and choose one of the audio options for dialing in or just joining with the computer audio. We'll give that a second for people to get that going. But also, if you have any questions along the way, you can click the Q&A button along at the bottom of your screen. Another one of our colleagues, Ben Follett, is online with us, and we'll be watching for questions and answering them as we go. Right. So today we're going to be looking at the latest versions of RISA-Floor, RISA 3D, and ADAPT Builder. The versions I have listed here are the latest versions that will be available starting, I believe, later this week, maybe early next week. And some of the main features that we're going to talk about are brand new and are in these programs as of these releases. So definitely be on the lookout for these releases in the next few days. So today's workflow is going to focus on starting the upper structure of a podium building in RISA-Floor, where we set up the entire model and check it for gravity loading. Then we transfer the model to RISA 3D to design the upper structure's lateral system. Now, what we're really excited about here is how we are now finishing this podium design in ADAPT Builder. We're going to see how the RISA model for the upper structure can now integrate with the lower post-tension concrete supporting structure. So now what we've got is essentially a one-stop shop for your podium building design, where you've got the entire building designed all in one family of programs that integrate together, they talk to each other, and that's going to make sure that your design process is both fast and accurate. So I'll be running through the RISA-Floor and RISA 3D structure, and then Nate is going to show us just how much time and effort can be saved using this new integration with ADAPT Builder. One other note about integration, we do also have 2 free utilities that can be used to link your RISA or ADAPT model with Revit. And in addition to these, RISA Foundation and RISA Connection for steel structures can also be included in this process for a truly complete building design, all within the RISA suite of programs. We're not going to cover those today since we're just focused on the podium structure, but I'd encourage you to visit our website or reach out to us if you're interested in seeing any of those programs in action. So with that, let's go ahead and jump into a model. So what I've got shown here is a screenshot from a Revit model. This was the starting point for this particular building. So like I said, we're just going to kind of get started with something already in progress one way or the other. So let me switch over to RISA-Floor. Okay. And we've got a 3D RISA-Floor model that looks awfully a lot like my Revit model. So this is a great place to get started. So since this is a model from Revit, I already have the majority of my geometry set up. Like I said, we have a lot of ground to cover today. So what I'm going to focus on is making modifications to a model like this that already exists in one form or another. This could be if it came from Revit, but I think you'll find this is also useful in any design process. These are tools that you're going to be looking for down the line. More than likely at some point, in any design, you'll need to come back into RISAFloor and make changes, make adjustments to your design. So we're going to talk about some easy ways to make those sorts of things happen. We have a lot of other material about getting models started and modeling from scratch and some of the basic stuff like that. So if you haven't already seen some of that content, please feel free to reach out to us and set up a product tour, or we can point you towards some of those resources, tutorials, YouTube videos, and the like. All right, so let me get into my modeling space here. So the first thing that I want to briefly talk about with this sort of model is setting up my design rules. So RISAFloor is geared towards optimization of new structures, as a lot of you probably know. And design rules are how you set up the parameters that the program will use for that optimization. So we have member design rules, connection rules, if you're doing things with steel. But let's take a look at some wall design rules since we're doing a wood structure in this instance. And we're probably mainly concerned with some wood shear wall design. I also want to point out that this is a wood structure typical for podium design. A lot of the same rules, the same things that I'm going to talk about today could also be applied just as easily to a cold form steel structure. So let's open up that wall design rules spreadsheet here. So like I said, this is where we're going to set up parameters that tell the program how I want these walls to be optimized when it's choosing different things for my design. The first thing I can set up is something like maybe reduce the maximum bending and shear check to give myself a little bit of wiggle room, something like that. I'm going to flip right to the wood wall studs tab. This is going to be where we input information such as the top plate, sill plate, the stud size that you want to start out with. Maybe I want to change this to start off with a 2x6 and see how that works. And then some of these parameters like I'm talking about are going to be minimum stud spacing and maximum stud spacing. So this is me telling the program, hey, start at 24, see if that works. If it doesn't work, go to 22, go to 20, all the way down to 16. And see, what the demand is for the axial loads for this wall for the studs. Same goes for selecting the header size. Can be a different material if you need it, no problem. The next tab over is going to be really important for us is going to be the wood wall fasteners tab. This is where I'm going to have all of my shear wall information. So the first thing I want to look at is the schedule. Pop this open by hitting this red arrow. And we can see that I've got a lot of different panel schedules available to me. I can just stick with American Wood Council OSB 2015 edition. And we can see, this whole gamut of shear wall panels that are available for my design. Single ply, double ply, different thicknesses. I can narrow down the thickness if I know that I want a particular panel thickness, like so. Different nail spacing, all of that good stuff. Really what I'm interested in is this shear capacity per foot. This is what we're going to be looking at the end of this wood structure design. How can we find the optimum panel sizing within this? So the program is looking through the schedule. It's looking for the shear capacity that works for your design loads and applies it to the design group, the design rules group. Hit OK on that. Some other options include different hold downs and chords. Similarly, we have databases of Simpson products here, different DTT, HDU hold downs, Simpson hold downs, Canadian product, the USP hold downs. Those are for the, usually for the base of your structure, and then chord straps that are going to be applied in between floors. Now, I've just got one design rule set up here. It's just called typical that comes with the program, but I'm probably going to need more than this. I can just hit enter in this spreadsheet and start creating new rules. And this is how I'm going to group things together, group like walls together and have them designed in one way. So this is both for the organization of your model, as well as fine-tuning your design to make sure that you have different regions designed for different loadings and really getting an optimal design. So for example, maybe I want something for my interior walls. I want a different rule for my exterior walls. I've got something going on the first floor, something else on the second floor, whatever subdivision that you need to do to group those walls together in a way that makes sense for your design, as many design rules as you need to set this up. Now, I'm betting that the way that this came over, all of these walls that I'm looking at probably just have that typical design rule set to them. Yep, they're all just going to be set to typical. I can see now that I've added a few, I've got those options, but I need to make some changes here. I need to, put those design rules into play. So let's look at some tools that allow me to do this very quickly. One of the tools that I like the most, I'm going to start off strong here, is this select by criteria tool. It's this little question mark button on the left-hand side of the screen. I unselected my entire model here, and now I can go into this and go to my walls tab. And I've got all sorts of different criteria by which I can select and bring into view the different walls within this model. So for example, I can select all of my lateral walls. And let's see here. Oh, I had a different option checked for that. There's all of my lateral walls like so. I can do the same and opposite, unselect all of my lateral walls. And then I did this already by accident, but I can combine that with my perimeter walls only checkbox. That's definitely a useful feature. Let's see, go ahead and unselect, select, there we go. So now I have my lateral perimeter walls only selected. So that's a nice, easy way to just, rather than point and clicking your way around the entire model, just get those in a couple of clicks here. When I'm modifying these walls, I can go straight to the same draw button that I would normally use and just go to the second tab. And this is where I can modify things, and I can modify them one at a time because I don't want to change everything about this wall. I just want to check the use box for the design rule and change these to my exterior design rule. Hit apply to all selected, done. So just like that, now all of the walls that are selected in this view are in this exterior family. So you can see how with a combination of different things, you can really get this, looking the way that you want it, or get into play the things that you need with just a couple of clicks. I also really like to toggle on some different model display options here to help me see what I'm looking at a little more easily, because not all of these were wood walls. I have a lot of, I have my stairwells in here, for example, that are a masonry wall. So that's not super evident right off the bat. I can go to this model display options up here, a little blue M, and I can go right in first tab is my walls. And I've got some different options for my labeling here. So for example, I could turn on my material type, hit apply, and now I've got a label that shows me, hey, you also had some masonry walls selected when you did that. Maybe you don't want those when you're making that mass change. So I can see those and unselect them and go back and change some stuff. A lot of those options are also available right here, just within this wall, labels drop down button. I can turn on the labels, I can turn on the thickness, things of that nature. But they're also available here within the model display options. And you've got a lot more options for things like beams, especially when it comes to the design results. You see things like displaying the bending check or the shear check, display that right on the screen there. I also really like the save selection feature. So say I'm not super confident that I'm going to get this right the first time, and I'm going to come back to it. It was pretty easy to select, what I was looking at here, but let's make it even easier. Hit this save or recall selection states for the model button. And I can just save this as a view. I think that these are going to be my problem walls. I think I'm going to have a problem with these. I'm going to keep coming back to them, and I want them easily accessible. Close that, do some other stuff, select some other things. And then when I come back, it's still there, retrieve that selection state. And that pops right back up just the way that I had it saved. And then I can do that same modification, change something about it if I need to. Okay. Let's also talk about spreadsheet modifications. One of the golden rules of RISA is that everything, can be done visually, can be done graphically, but everything can also be done within a spreadsheet. So it just kind of depends on your modeling style and what's going to be easiest for you, what's most appropriate for your situation. So for example, if I want to make some mass changes to, say, my beams, I can go right into the beam spreadsheet here, and I can use we call a block fill command to make some changes sort of all at once. So let's say, for example, my options here for the start and end boundary condition for each beam is pinned or fixed. I can hit Control F. I believe I can hit Control F. Yep. Control F is block fill. You can also right click and find it in the menu, but Control F, block fill. Type in fixed, hit OK, and it changes that entire selection to fixed. Great way to make changes in mass by way of the spreadsheet there. If you have like things grouped together, I drew all of these all at once. That's a great way to make a change to just a block of things in there. I could also use this spreadsheet to investigate my model. So let me unselect some things so I have something to start with. So say, for example, I've got, a bunch of rectangular double sections in here, and then suddenly a glue lamb section. Where's that guy? Right click, select marked lines in current view. Let me just kind of make sure that that's what I wanted it to be. Yeah, that makes sense. I like that that was a glue lamb. That wasn't a mistake. I'm able to verify that. Go find that guy very quickly. You can also, within a spreadsheet, use the block fill command. I like to point this out just for people who don't know. Use the block fill command to fill in a checkbox. Block fill, enter in something. I always enter an X. Well, it's not going to let me do that because it doesn't want those to be in outrigger. Let's see, a load combination spreadsheet would be a good place to do that. If I want to exclude all of these load combinations from my result, I can fill it with nothing, and that unchecks all the boxes, or fill it with an X, and that checks all the boxes. So that's a good fast way to select and unselect a group of load combinations, for example. I do that a lot. Another good modification tool to be aware of is math on block as well. So let me go into something where I've got some numbers to play with. So let's say I've gone in here and I've entered in a bunch of random unbraced lengths for these members for some reason. This is just corresponding to something in my design. And then I find out that they're all wrong by a factor of 2. No problem. Control M is block math or math on block. You can also right click, like I said before, right click math on block. And I can divide this entire block by 2. Add, subtract, multiply, or divide any of the basic math operations. Divide the whole thing by 2. Easy, done. That's a great way to make modifications to things like, loads might all be off by the same factor, things of that nature. And anything that kind of stems from an outside calculation, you got one factor wrong, no problem. Can make a change easily. All right. Another thing I want to look at changing, let me turn my, what did I have on? Wall thickness, change that to none. Another thing I want to look at changing is the diaphragm edge. So the way that this came over from Revit or from wherever else is that you see this blue outline here. This is actually the edge of my diaphragm. It's currently, it looks like it's set to a 12-inch offset from the center line of my walls. That's a little bit much. Maybe I want to do a little bit less. Go into this modify diaphragm and openings tool. Again, it's the same tool as to draw things. It's just the second tab. And I can modify the overhang distance. I can modify a lot of things about it, but let's just modify the overhang distance. Let's make it something a little bit less, 4 inches. I can just apply to all selected edge segments rather than clicking my way around. Hit apply, and we see that brought that in a little more snug, so I don't have that much of an overhang anymore. Another important thing that I probably need to look at is the decking. If this came over from Revit, it might not be set up with the decking, in a structural way that makes sense. So if I turn on my decking display, it's these gray lines running plane horizontal. That's the direction of my load attribution. And I can see that that's going to be right for some areas, wrong for a lot of areas. In fact, I think it's wrong for the majority of my structure. So I think I want to change the default decking direction to be, plan 90 degrees, currently set to 0. I just clicked into the floors tab here. I've got the second tab is beam floors and the deck angle. I can use that block fill command again, 90 degrees. Okay. Now I've got the majority of my decking is all running the correct direction. Then I just need to go in here and change a few of these sections. So I can do this a number of ways. I can assign the deck, go in here and assign a wood deck. Just change this to, I'll box the perimeter because I've got just some nice boxy areas here. We can see it overlays that new horizontal decking over top of the default. I can change that view setting. Oop, I didn't actually mean to do that. Undo, no problem. And I can change that in here. And I would just work my way around my structure and, change it anywhere I needed to change it, like this corridor, for example. Okay, let's look at that as applied, or I'm sorry, without default. That just shows the ones that I've edited myself. Okay. Next thing I want to look at, and this is going to be important as well, is my area loads. So area loads are applied, again, like the decking, they're applied by default across the entire structure. I go in here to my area load definitions spreadsheet, and I can see with my color code that it's using by default this office load across the whole thing. It's not an office, let's call it, residential or something. But, maybe I'm good with the dead load, the live load. It can be reducible, which is important. It's very nice. Maybe I've got a storage area. Maybe I want to change that to mechanical or something like that. My public could be a corridor, whatever you need for your area load definitions. 100 PSF for the corridor, that makes sense. So then what I need to do here is go in and just draw in some area loads that replace the default loading. So again, I want to have the default that makes the most sense for the entirety of my structure, or the entirety of my floor, I should say, and then just go in and change the things that need to be changed sort of onesie twosie. So for example, I can draw in this corridor by drawing a polygon around the corridor. I probably should have zoomed in a little bit, but if I can just do some careful U-shaped clicking around my structure like so, there's a corridor loading in red. And remember, that replaced the default loading, so it's now completely just a corridor load. The exception to that is if you have the additive checkbox checked. This is useful for something like sprinkler piping, which is why we use that as an example. That would add to the loading because, sprinkler piping is underneath. I want that to be there. Okay. Let's see. Another useful tip, it's great when you can, oops, wrong. It's great when you can, when you have very boxy areas like this or something like that, but you can also turn on universal snap points when you're drawing these area loads. So for example, if I turn that on, and let's say for some reason I had the mechanical area load, wasn't this whole area, it was just some amount in here. You can see that when I'm hovering, I get coordinates because now I have universal snaps turned on, and I can click to, invisible snap points behind the model here. Now let's see, well, if I could click them correctly. But let's see, we could also turn on our node labels. That's also helpful to kind of allow you to see what's going on with this this image, this picture, and draw in things correctly. And the other thing that I like to do that people don't often think of is use the drawing grid, this kind of 30 by 30 square that typically pops up and everybody just goes right past it and starts drawing. Take that and let's modify that. Let's not use this just generic kind of useless grid that's up here in space. I would recommend having a DXF ready to import into this model that is an outline of your area loads. So if you have, a quick traced drawing that you can do of corridors, of public spaces, of where your sprinkler layout is, that might be something that you already have or that's easier to draw out in AutoCAD. Import that as a DXF and it'll show up right behind what you've already drawn here. And then you have some specific snap points to draw those loads in. So I think that can be a really useful tool for people who get to that point who are drawing in kind of funky area loads, is just to, this drawing grid isn't just for getting started. It's very useful down the line in your project for something like area loads as well. Alrighty, at this point, I'm going to switch over to the same model that I already have a solution run. Just doing this because it takes about a minute to run the solution, probably less, but that's not something that I want to spend time with for a webinar. So you can see when I run my solution, I get all sorts of results for, I had different wood product joists as my interior members here, 2x across my hallway, all my end reactions, all of that sort of good stuff. And again, we have a lot of information about, where you can go at this point. We can view detail reports for members, things like that, checking out your results. We have a lot of other materials on that. available as well. So I'm going to sort of skip ahead and get right into RISA 3D. I'm going to transfer this model over, do our first integration step. So I hit my director button up here, RISA 3D. It prompts me with the wind loads generator. So I just enter in my site-specific wind criteria. I believe I designed this in Louisiana, so there were some serious wind loads. It's going to give me the floor-by-floor summary of those wind load results that get applied to each diaphragm. I'm good with that. I hit OK. I believe I had no seismic code selected for this model, so my seismic load generator did not pop up, but normally it would. Let's see. So, but same deal there. You just enter in your site-specific criteria. So, what happened? RISA-Floor shuts down. RISA 3D opens up. And what's happening here is that it's still looking at the same file, even though it's a .rfl file, RISA-Floor file, it's opening it up in RISA 3D. We can see that I get this little FL floor icon here to sort of indicate that that's what happened. And it's going to read this model in RISA 3D so that I can finish out the lateral design of the structure. RISA-Floor handles all of my gravity loads and does the majority of my input. And then RISA 3D is where we finish this out. Now, if you're unfamiliar with this process, and if you're like me, you probably do everything and anything in RISA 3D, but so you're going to find that there's shockingly little work to be done at this point in RISA 3D. I'm used to doing my entire project here, but really my entire project is almost done. I did so much of the setup work in RISA-Floor. We can see here that I've got sort of the wrong button. I've got the outline of my project here. Turn on those diaphragms so you can see it a little better even. So what came over here was just my lateral elements. So none of those interior beams and things that I don't really want to be part of my lateral system. I just wanted those shear walls, maybe a couple of beams here. So I have just the lateral information. And then I have all of the gravity only members in the form of, the loading that they apply to this structure. So you can see a lot of loading information came over from this. I haven't entered in any of this myself. It was all automatically generated. And if I flip back and forth between 3D and floor, if I need to go back and make a change, and I come back in here, all of this loading is going to be updated automatically as well. So it's keeping track of all of those loads for you. It's always going to be, the most up-to-date information when you're switching between two programs, so you don't have any errors in translation. It brought over, those wind loads that were generated. We see them here at the center of area in the diaphragm, and each diaphragm up here. So like I said, I have very little work to do in here. If I had a steel building, for example, maybe I would need to draw in some braced frames or just draw in some other lateral elements. But in the case of a shear wall building, I'm pretty much done drawing. I'm ready to go. All of the loading information came over already categorized: dead load, live load, wind load, broken out into all sorts of directions and partials and things of that nature. Several hundred loads here handled for me. So all I really needed to do was set up the load combination spreadsheet. I've already done so in this model. I did this by using the load combination generator. If you haven't used this before, it's definitely a lifesaver for this sort of mod. It's really geared towards this sort of operation where those loads came over already categorized for me. So when I go in here to the wind tab of the generator, I select what code I want to use, do X and Z. I want it reversible, so I'm checking 4 directions. I want those eccentricities. I want those partial combinations, roof wind load options, whatever you need. With one click, generate, which I'm not going to do because I've already done. It's going to generate, how many load combinations here. And this is just wind, 71 load combinations, all different directions, partials, uplift combos here at the bottom, everything according to the IBC code that I selected. I've run just, a few of the important ones here to take a look at the results of my structure. So at this point, I'm doing sort of my typical RISA 3D operations. Maybe I'm checking out, say, the detail report for this here shear wall. And, I check that everything here is passing. Okay, where are my, my straps, my hold downs, my moment and shear diagrams. I get whatever detailed information I need from within this detail report. I'm happy with this. Maybe I can print it off to a PDF. And at that point, I've pretty much wrapped up the the 3D analysis. Something that maybe I want to look at just for fun, we'll say, is let me isolate a couple of walls here so it's not too busy. And if I turn on my deflection, I sort of see the internal breakdown of the wall that happens behind the scenes, the sort of plate submeshing that a finite element analysis is used to design these walls. And something that I'm just curious to look at is my reactions, how the reactions at these walls are handled. So I get nothing under the windows because I'm using a segmented method, but we see just a whole lot of point loads that represent the reactions at the base of this wall. So you can imagine this is just for one load combination, just for dead loads, and this is just 3 walls. You can extrapolate just how many reactions I'm dealing with at the base of this structure when it comes to what's happening at the bottoms of these walls. So just keep that, maybe keep that in the back of your mind for what we're going to handle here. Turn that back off. But yeah, at that point, if I'm happy with the results here, I can print off my report. I think I'm pretty much good to go with this. And like I said before, it's very surprising how little work I needed to do in RISA 3D to wrap up the wood portion of this structure. So with that, the upper portion of this structure is done. And now we're going to get to the good stuff. I'm going to hand it off to Nate, and Nate is going to talk about the Podium side of things in ADAPT Builder. Nate, ready to go?
I am. Thank you, Alan. I had a frog in the throat with the first few words out of my mouth. Leave it to a live presentation. Hello, everyone. Thank you for attending. Thanks, Alan. That was fantastic. As Alan had said, in the past, before we were doing technical sales, we did design work. And for me, I mainly focused on Podium designs. And honestly, I never touched a superstructure. So this is perfect for me because I always had the superstructure handed to me as far as the loads and whatnot. And honestly, it took several hours. Several hours is actually putting it lightly, several days to do one of these designs. If any of you are familiar with a Podium design, I'm sure you can sympathize with me on that. So here is our RISA 3D model that Alan had just shown us. Let's set it aside for a moment. We'll come back to it. I'm not going to give you the grand unveiling, if you will, just so I'm going to make you sit through and listen to me talk for a little bit. For those of you who are not familiar with ADAPT Builder, I think this will be helpful. For those of you who are using an older version, also be very helpful because there are 2 things that really eat up your time in a Podium design, specifically when you're looking at the Podium just itself, right? One of those being the loading. The loading is a pain in the butt, getting all the loading over. The second thing is getting the tendons. The tendons is also a very difficult aspect that we have to deal with. So let's go ahead and discuss really how we get loading into this. Now, I've gone ahead and used, for example, our Revit import and created our geometry here, right? So if I go ahead and show a 3D rendering, of course, it shows up on a different screen here, right? We have our kind of Podium that I've laid out. I took it a little bit further than the screen shot that Alan had. I went and added a pool because let's be honest, Podiums are fun. They're never just simple flat plates. There's also some slab steps going on in here, right? Lots of complicated stuff to look at. So with that in mind, let's go ahead and start with adding some loading just for our Podium level. I'm actually going to switch to an ISO view just because it'll make it a little bit easier for me to select some of these components. So I have some loading kind of written down on the side here. For example, let's say we just have kind of some uniform loading on the main slab area. If I just hop into the loading section, I can just go ahead and quickly apply an area load. Let's go and do a uniform dead load. Pretty quick and easy. We'll create that and we got some crazy scale on this loading. And that's because when we add our dead load for our pool area here, obviously there's going to be a lot of weight. Water is not light. So let's go ahead and add some water or loading due to the water, which obviously is going to be pretty heavy. I think this is about a 5 foot deep pool. So we'll do 320 pounds per square foot. And you can see everything kind of gets scaled appropriately, with that water load being the largest of them all. Cool, so we have dead load. Let's go ahead and add area load. Maybe this residential area is just, our typical live. So I can quickly go in here and just throw in 40 PSF live, not a problem. And then maybe in this courtyard and the pool areas, maybe we have a little bit heavier of a live load just because it's, kind of a gathering area. Maybe we'll do like 60, for example. Right, so we'll go ahead and do that. Right, we've added loading for this podium level, and you go, Nate, that wasn't that bad. You've been talking for maybe 5 minutes, and you've already added the loading. Yes, the loading for this floor, not a problem. It's the superstructure loading, right? That's the one that those of us that have done a podium design, we really dread it. Adding in all of those line loads, all those point loads, it's tedious. It takes forever. So let's go ahead and show what that looks like. I'm going to go ahead and actually turn off my area loads. I don't need those anymore. So let's go into a top-down view. We have our geometry. We're good to go with our area loads. Let's get the superstructure stuff in here. So I'm going to go ahead and hop back over to 3D real quick, right? And I've ran the solution similar to Alan. He was kind enough to share a superstructure model with me, so I didn't have to do any of this. And I've got my solution. And the next step is I simply just go File, Export, and now we have an ADAPT Builder file export. So I just click this and I navigate to my file here. I'll do that Podium webinar file. We'll just click Save. Yeah, that's fine. I can override it. And just like that, it's done. So what I can do now is if I hop back into Builder, I'm more or less done with 3D. We've added this nice new shiny import from RISA button under the loading tab within ADAPT Builder. So if I just click this, I can now browse to the location that I have saved these loads. And if I go ahead and jump in here, there's the file I've created. Go ahead and click Open. We'll click Next. And it's going to lag for a second. And I will show you exactly why. If we go ahead and scroll through this real quick, we've picked up a whopping 5,033 point loads that are coming in from RISA 3D. If you recall, Alan showing kind of that wall in that isolated view and seeing, all of the loads coming in from the shear walls, this is where they're coming from. Not only that, though, we also have some line loads as well, right? These are particularly due to our gravity elements. So they're there, they're coming in, they're going to be coming in. And we have about 129 of those. So I'm going to trim this down a little bit. I'm just going to get rid of my wind load partials. Those are obviously due to the eccentricity involved. I'm just going to turn that off just for the sake of this webinar. So we're not dealing with a ton of loading. I mean, let's be honest, we're still dealing with quite a bit. Just turning those off, trimmed it down to about half the number of point loads. So we still got a lot of loading that's coming in. I don't know about you. If I could see every one of you, I doubt any would raise their hand as a volunteer to put this loading in. Let's be honest, we don't have the time for that. So let's click Next. And now we have the ability to map these loads to existing load cases within ADAPT Builder, right? Within RISA 3D and RISA-Floor, we as engineers understand that DL stands for dead load, LL stands for live load, so on and so forth, right? Builder doesn't necessarily understand that. In Builder, dead load is actually spelled out as dead load. So easy enough to just apply that. Live load, obviously, live load here. LLS is live load special. I'll go ahead and assign that to live load. And this is where it would get a little bit interesting. For those who are familiar with ADAPT Builder, roof live load isn't built in automatically. You can obviously add it as a load case, which is what I did. I went ahead and added in a roof load case here. I actually called it roof. If I didn't, I could leave this as no. And if I leave it as no and I import this, the program will automatically create a load case for me, which then I can then apply it in my load combinations. But since I already have a roof load case in here and the load combination set up for my roof live load, I'm going to assign it there. Similarly, I have done the same thing with WLX and WLY. So we're just going to map everything, keep everything nice and tidy. Let's go ahead and click the Move Imported Objects to XY position. Obviously, this is important. We need things to line up. Otherwise, we're not going to necessarily design this podium in a correct manner. So let's go ahead, click End, and give it a second. And you can see some loading that pops up, but we still have to move it. According to the prompt of the program, we got to locate this. I know this corner corresponds to this corner. And the loading has been moved and has been imported. Let's do an isometric view and take a moment and appreciate the madness that came in. I'm going to turn off the line loads because they're pretty crazy. Let's just look at our point loads right now. Just want to take a moment, let that sink in, everyone. I just brought in all the loading from a multi-level superstructure onto a podium in probably 5 minutes. If I didn't get all long-winded about it, I probably could have done it faster, right? This is super, super powerful. Let's go ahead and take a little bit of a closer look, right? This is all of the point loads. For example, maybe we just look at our dead loads, right? Okay, makes sense to me. I think really what we want to look at is potentially wind loads, right? Wind in the X direction within Builder, you can actually see, we get some uplift and some compression over on this side, which makes sense. And likewise, wind load in the Y, we have kind of the same situation. And not only is it uplift and compression, but you can actually see there's a horizontal force associated with this wall. In fact, if I click on the point load, I can actually see the magnitude of this point load, which is fantastic. And hey, maybe I need to make an adjustment. I can totally do that. You're not locked out. You have the flexibility to then make any changes that you need. Now, some of you might be going, well, you're missing some walls. No, that's simply because if we go ahead and turn on our dead load, for example, and we show our line loads, right? You'll see more of our walls. And that's simply because if you recall, in RISA 3D, our shear walls are discretized down into a finite element mesh. And so when they come over as point loads, whereas our gravity elements currently come over as line loads. And so this is kind of a good key way of identifying, hey, I know that this is actually a shear wall. Same here, whereas these ones over here are gravity. Awesome. Let's go ahead and turn off some of our loading now. Really, I could go ahead and apply wind loads for my podium structure using the built-in wind load wizard, right? Alan went ahead and said we're using 144. Well, that's wrong. I don't put that there. I want my wind in the 0 degree and include the orthogonal, for example, and the wind speed. I want 144. We can go ahead and apply these forces, right? We have windward, leeward forces for both the X and Y direction. So pretty straightforward. We'll go ahead and turn those off as well. Just like that. And so our structure is loaded. That handles one of the tedious aspects of podium design in a matter of minutes. I challenge you to find any workflow that is going to be faster. Honestly, I think this is a game changer for those of us who are doing podium designs. But what's really cool is this isn't just limited to podium designs. I obviously could have imported loads into a post-tension mat foundation or a mild reinforced foundation or a mild reinforced podium structure if for whatever reason you wanted to use Builder in that situation, right? This integration between the RISA 3D and ADAPT Builder workflow can be used more than just in podium designs. So with that said, that this is an actual podium structure where we're going to have some tendons. So let's go ahead and add some tendons. Now, none of this is entirely new. If any of you are using the latest version of Builder, this is probably going to be a recap. At least I hope it's a recap, because if you're not using these tools, you really ought to be. It is a huge time saver, and honestly, just will help you come up with your designs in a more efficient manner. So I'm going to go ahead and start adding tendons. Now, Normally, when you're going through Builder, you have to set up X and Y support lines. I did that already so that you guys didn't have to watch me go through that. We have several videos already out there that discuss the process of doing this. So I've already gone ahead and done that. So let's actually go ahead and add some tendons for this guy. So I'm just going to select some support lines in particular. For example, I'm going to grab these two and hop over to my map banded option. So if I just click this and it showed up on my other screen, if we then go ahead and input some of the options here to map tendons for this, I'm going to go ahead and use the design strip width. I'm going to target a pre-compression, a percent self-weight to balance. And in fact, let's go ahead and do, a self-weight and dead load to balance. And I'm going to idealize this as a group with an offset of 1. I specifically selected, this support line and this support line because I have these openings and I don't want the tendons running through them. So I'll do that and kind of keep the defaults. And if I click OK, it'll add those tendons, right? And go just like that. And this one, I'm actually going to go ahead and he's a little close for comfort on that pool. I'm going to move him. I don't necessarily like how close he is. Not a problem. It's easy to just kind of grab those points and move him just like that. Awesome. Let's do the same with this support line and this support line. Right. And Builder's liking my other monitor today. We'll do that. Instead, we want -1. All the other input has been kept the same. So I click OK. Adds those tendons. I'm going to adjust this one as well. It's not hard, so bear with me. Just a little modification like that. Awesome. And then these support lines, there's no openings kind of adjacent to them, so I can just map band it, and I'm going to actually change the setting here where I want them idealized as 2 groups with maybe 1 foot offset, and we'll click OK. Right now, this tool isn't perfect. It's not coming up with the final tendon designs, and in fact, there's actually a little bit of an issue down here. That's really not a problem. I can just select the tendon, right click, and delete the vertice. There's also other ways to manipulate the tendon layout, points, and control heights. We'll touch on that here in a second. So that more or less covers it for our banded tendons. So let's go ahead and add some distributed tendons. I'm actually going to use my smart tools to do this. So we're going to go ahead and assume that we need 3 tendons spaced every 3 feet. So I'm going to set up some default settings here. I think I'm going to keep those as is. And let's go ahead and create a tendon. And this is super easy. For those of you who have not seen this or are not familiar with ADAPT Builder, I simply draw a construction line, that red line through where I want a tendon, and it automatically adds it for me, picking up my high points based off of where I have a banded tendon. Now I could go ahead and go through and just keep adding tendons as I'd want, but there's a faster way to do it. There's always a faster way. I'm going to actually add a tendon up here. So that adds a tendon there. And more or less what I'm doing is I'm outlining or defining the bounds of where I'm going to have distributed tendons. I obviously want them through this whole area. And so now that I've had kind of this bounds of our tendons, I can go ahead and use the map distributed option in the smart tools and go ahead and say, hey, I want to add tendons at a max spacing of, let's say, 3 feet. Now don't blink, because as I draw this line through here and I click one more time, it's so fast of adding distributed tendons now. If you blink, you might miss it. Ready? Done. Adding distributed tendons with the new smart tools. If you're not using the latest version of Builder, you definitely need to use it. This is going to save you so much time. Or if you're not using Builder, you need to get Builder, because this is also going to save you so much time. Awesome. So it's, again, not entirely perfect, right? If I go ahead and open up my smart tools, we can adjust things on the fly, though, such as if we go into the Edit tab, we can change shape, right? All the shapes are this reverse parabolic shape. And there's some walls that we have in here. Not a problem. I can go ahead and just say, hey, really, the profile over these walls should be straight. And I just kind of draw that all familiar red line through any tendons that I want to change. And it's not very difficult to quickly come up with changes. For example, another one, hey, this span is pretty small. Maybe we want to raise the profile of this tendon. Okay, let's change it to 6 or something. Again, all that familiar red line and just draw it all the way through. Oh, we have a little bit of a graphical issue. If I just reopen it, I think we'll be okay. Let's see. There we go. Do that. I can do similar with this one, right? And change all of those to 6. And I can go through and keep adding and manipulating and making changes, but that's not really what we're here to do. It's really to kind of see, hey, what this podium workflow looks like. And we have some tendons added. Let's go ahead and actually dive into what the results are, right? I didn't do a lot of changes. So we'll just kind of see what the program has picked for us. So I can go ahead and hop into my analysis tab, and we're going to go ahead and execute the analysis. I'm not going to do it for all the load combinations. Obviously, we have a limited amount of time, so I'm just going to do a couple of gravity, a service gravity, a strength gravity, and maybe I'll do, well, let's grab this strength wind combination, for example, that I've created, and we'll just click OK. So now the program is going to go through and get a finite element solution for us with all the tendons we just added, all of the point loads. As you can see, there was a little bit of a slowdown on the point loads. I mean, I think we can appreciate that it's okay that there was a little bit of a slowdown considering we have almost 3,000 point loads within the program right now. And we're going to get results, FEM results for our podium, just like that. So with FEM results, I'm going to go ahead and turn my tendons off. We don't need those showing right now. With FEM results, I can see things like deformation of the slab. Let's go ahead and, we can see deflection, for example, right? Not too bad. For service total, we're at about 0.4 inches of deflection, right? Maybe have some problems in this area with when it comes to long term, but that's not looking too bad in my opinion. Good starting point. But really when we get into the design of the structure, right, we're wanting to see things like shears, moments, and for PT, stresses, pre-compression, right? So that's where we go into our floor design tab. We're going to want to go ahead and design all the sections for those support lines I laid out. So what this is doing is it's taking section cuts through our slab to integrate the FEM results that we just obtained in the last solution. Now, this is going to take a minute. Obviously, there's a lot of section cuts. There's a lot of results to compute, and it should be done here in just a second. And there it is. So if you have a keen eye, you may have noticed that the design sections is now available here. So let's go ahead and take a look. Let's turn on, for example, our Y support lines. It's a little messy. These are all the section cuts that the program designed for. And we can see things like our moments. Let me turn off the sections. We don't need to see those right now. We can see all the moments for this guy. Right now we're looking at the service total load combination. We could always switch to our strength gravity, for example, or using all of the wind loading that we brought in from our superstructure. You can check that one out as well. Let's switch back to service and take a look at something a little bit more interesting. For example, our stresses. Oh no, we have some failures. Let's go ahead and I'm going to turn on my section cuts again because that'll be easier to see, and we can take a look. Anything shown in pink is where we're having an overstress issue. Okay, right there, doesn't surprise me. We had a ton of deflection. Again, right there, still doesn't surprise me. Ton of deflection. Let's check our other direction, for example. That looks pretty good. Obviously, there's probably some optimization I can do with our PT. It looks like if I actually switch to bottom, we're getting almost too much uplift in some of these areas. And so I may have put in a little bit too much PT. Some weird results going on right there. This is an RC portion. Actually, I know exactly what happened when I mapped my tendons. I wanted to remove the tendons from this slab area. It's super easy to do, but for the sake of time, I'm not going to show you how to do that. That's why we're getting this stress spike there. Let's go ahead and actually I want to check the other direction as well. And we can see, yep, okay, makes sense that high deflection in this area is causing some overstresses in that portion. Awesome. So the other thing we could really do if we wanted to is check punching shear, right? That's always important, especially for a podium design. Let's go ahead and execute a punching shear check. And this will do for all the load combinations that we've analyzed, obviously for strength. So we can go ahead and check, let's check our wind strength combination. And again, now we have a punching shear section and we can see the stress check, the stress ratio. Right? Looks like everything is actually okay for this wind combination. You can see, yeah, those stress ratios are below 1. And we can verify that this is actually working if I switch to strength and live in this situation, right? Looks like that combination is controlling based off of, you know, the limited combinations that I analyzed for. So now from here, we'd probably do some massaging of the tendons, right? We had some top stresses and some bottom stresses, but really not too bad. The program did a pretty good job on picking the number of strands for our banded direction. I did a simple hand calc on targeted pre-compression for our banded direction and just laid out the tendons. Needed to do some manipulation of the profiles, but not anything too crazy. So from there, we'd probably go about, after maybe refining the tendons, go into generating our reports and you know, submitting this. And so we've more or less designed a superstructure and the podium for that superstructure in a matter of an hour. Obviously, it's not ever going to work out this well in the day-to-day, but this is obviously going to save you a bunch of time when it comes to doing these designs. So with that, this more or less concludes the broad overview of how you can leverage the integration of the RISA 3D and ADAPT Builder PT for the design of podium buildings. And obviously there's way too much for us to cover in just an hour time frame. However, that being said, Alan and I are both more than happy to schedule a one-on-one software tour with you and your firm to discuss how RISA and ADAPT can improve your design workflows or any of your other design needs. We've listed our contact details here, so please, by all means, reach out to us should you be interested in learning more about what you saw today, or even any of our other software solutions. Maybe you're not doing podium designs. You know, we have a lot of programs available to help you out. And so again, we're happy to help. We did design work for several years and we know what it's like being an engineer. So we want to help you guys save time, effort, and energy. So for more information, you can also visit our website where you'll find our help file, our tips and tricks, and links to other useful videos that cover topics that we kind of breezed over today. With that said, we appreciate everyone's time. We hope you have a fantastic rest of your week. Thanks and bye-bye.